Okay, so we have a quick run through of the work for exercise 11b from the Pearson Applied 1 textbook. So this is about variable acceleration using calculus in your variable acceleration. If we use Suvat equations for constant acceleration, sometimes your acceleration varies with time, in which case we use some calculus. So if we start off with our displacement, we know that if we were to differentiate the displacement, differentiation always gives you a rate of change. And the rate of change of displacement is always your velocity. So if we differentiate our displacement, we'll get a velocity formula. And similarly, if you got your velocity formula, and you differentiate again, you get the rate of change of velocity, which is going to be your acceleration. So we have a way of getting from a formula for displacement to velocity to acceleration. Obviously, we'd find it useful to go the other way as well. So the opposite of differentiation, you just integrate to go the other way up the ladder. Okay. When you look at this, don't try and memorize it. Try and understand that when you differentiate displacement, you get velocity. Differentiate velocity, you get acceleration. Otherwise, if you just try and memorize it, you'll end up mixing up your differentiate and integrate. Okay, so if we go through an example, particle P is moving along the x-axis at time t seconds. The displacement x meters from O is given by this formula, and we need to find the speed of P when t equals 3. The value of t for which p is instantaneously at rest, and the magnitude of acceleration of t when the acceleration when t equals 1.5. So first of all, if we've got our displacement formula, we know if we differentiate that, it's going to give us our velocity formula. So we've got a formula for the velocity now, and we're trying to find the speed when t equals 3. So if we sub in 3, then we get 76 meters per second. So in this case, the speed is also 76 meters per second, but you need to be careful, because if we've got a negative value there, then the velocity can be negative, but the speed will always be positive. So if you've got a negative value, you'd have to make it positive. Part B, the value of t for which p is instantaneously at rest. Obviously, if it's at rest, then the velocity is 0. So if we just set the velocity equal to 0 and then solve it, you get t equals 2. Okay, so it's instantaneously at rest when t equals 2. And last one, the magnitude of the acceleration when t equals 1.5. So if we differentiate our velocity formula, we get the acceleration is 12t squared. So we just sub in our 1.5 and we get 27 meters per second squared. Okay, so basically this section is all about just differentiating, subbing in your values. Be careful about things like speed and velocity, because speed is the magnitude of velocity. With acceleration, again, it will say if it's magnitude or the actual acceleration, because the acceleration can be negative, but the magnitude of it can't. Okay, so go away and have a go at some of those questions.